Okay, so graph each of these functions. I don't know why I have just one plot here. Okay, ready? Oh, I don't even like this question. Let's do something different. I'm going to make something different. Let's do that one. I'm just making new questions because these are too easy. I'm never going to give you one that's this easy.
I don't know how to do it though. Say that. Gotta be honest, Amanda. Pre-cal is about honesty.
Okay, 2 new questions. There's my new questions. Okay, ready? Exponential. What's the base? 2. So I just start. Don't even look at anything else. Start with a 2. So 2 to the negative 1, 2 to the 0, 2 to the 1. So 2 to the negative 1 is half. Anything 0, 1. Okay, so this is exponential, so these coordinates are okay, now that I have 3 coordinates, what is this doing to it? Down 3, that's a D. So I'm going to go x comma y minus 3. Down 3. Okay, a half minus 3. 1 minus 3. 2 minus 3. Okay, then I'm going to draw those 3 points. What about the asymptote? What do I know about it? Where should the asymptote be? Negative 3 on a flat like that. So negative 1 comma negative 2.5, 0 negative 2, 1 negative 1. So what's the general shape? Something like that. Are we okay with this? Base, get 3 points, then talk about your ABCD stuff. Okay. Then this one. What is your base? Your base is 1/3. So 1/3 to the negative 1. 1/3 to the 0. 1/3 to the 1. Okay, so I do it every time. What's the base? I do those 3 things. Okay, then I ask myself ABCDs. What's going on? This is a A. So I'm going to do x comma 2y. So negative 1 comma 6, 0, 2. What is 1/3 times 2? 2/3. Okay. So where should I start my asymptote? It is still at 0 because I didn't go up or down, so it doesn't go up or down. What do I know about my shape because the base was a third? If the base is 1/3, what's going to go on with this? Decreasing. This one, it was increasing because it had a base of 2. Obviously, reflections mess all that up, but so it's decreasing. Okay? If I ever have to just make a graph on my own, I have to put some label. So do you notice how I did a 1 and a 1? Just to show you a label. Okay. When you're graphing, what's the base? Always the same start. What's the base? 5. 5 to the -1, 5 to the 0, 5 to the 1. Okay, so start the same. I don't care if it's an exponential or a log, we just are going to start the same. Because this is a log, now is when I change. How do I write the coordinate? 1/5, comma, -1. Remember, that's the part that changes. Before, the exponent was the input, result was the output. Now my result is the input, the exponent's the output. Okay, so there's my 3 basic points, and then what? A, B, C, D stuff. That's a C. So x minus 3. I'm moving left 3. I'm going to have to move left 3. Okay, do we want to do this fraction one? What's 1/5 subtract 3? -2 and 4/5. 1 subtract 3, -2. 5 subtract 3 is 2. So I better have just a general sense of how log shapes look and where my asymptote is. So we moved left 3. So my asymptote is vertical, and my log shape will look like that. What is the domain of this graph? So x values are from what to what? From -3 to infinity. What kind of bracket do we want to do here?
Square.
Round. The reason is because x never touches -3. There's an asymptote there. It doesn't touch. Okay. Rewrite in exponential form. So let's just label these. 5 is the base, result equals exponent. So now I'm going to go 5 to the 3 equals 125. Okay, now switching it up. So base, exponent, result. I'm going to move it to log. So log base result equals exponent. Okay? I gave you a couple of those simple ones on the test, so hopefully those are the freebie points. Okay, solve. So how would I think about solving this? What would be a good idea? Yeah, that's my strategy. Change the form. Okay, so change the form for me. If I'm in log, I'm going to go to exponential. So what's the base?
3.
To the? We got that. Base 3 to the 3 equals that result. Everybody is aware that they have to have Does everyone have this firmly memorized? Right? You see how important it is? Log base result equals exponent. Okay. Do we know 3 to the 3? 27. Okay, I'm going to isolate here. So minus 7. Divide by 4. Okay, I'm not done though. I shouldn't have even circled it quite yet. I'm not committed to this answer yet. What should I do? Check. When I plug 5 in, 4 times 5 plus 7, would that be positive? Yeah, so we would be good. Okay, next. When you look at this, what strategy type is it? Same base question. That's the type. Same base. So the 5 and the 1 over 25 could both be written with a base of 5.
What's supposed to be a 5 to the 1?
Yeah, I don't know. 5 to the 1, you don't really,
Do we have to write that in?
you don't know.
How could you wrote that?
I don't know, just
Okay,
just to show you that it's 5 to something. Don't write it if you don't want to. And what should I do with this? How do I get a 1 over 25? 5 to the negative 2. Once we have both as a base 5, we're just going to conclude this exponent equals that exponent. What do you do when you have exponents to exponents? You have to multiply.
What?
Right here, an exponent to an exponent, you would have to do a multiply on that, right? Do you remember from grade 9 and 10?
Nope.
So this was something you would have had in grade 9, I believe. So this would be 4 to the 16. That was the rules you talked about. Okay, algebra, isolate, so I'm going to plus 6x and minus 9. There's no restriction about negatives on this, right? You can have negative exponents, that's fine. Yeah. Yeah. So you, no, that's to know on a log if the result is positive. If you like, you have your calculator, you can check your answer. Do we know that? How do you check your answer? So if x is -1, this would be 5 to the 8. If the x was -1, what's 3 times -1? -1. -4. And then you could enter that in your calculator and see if it makes the same number. Right? I don't tell that usually because you normally wouldn't have a calculator on this test question. Okay, use benchmarks to estimate this value. So we're just estimating. So benchmark is things you know. So use things you know to estimate this. So here's what my brain is thinking. 3 to an exponent has to give me 40, right? Log expressions are always equal to what the exponent would actually be. So here's your benchmarks. What do you know about 3 to something? Give me something. 3 to the 3 is 27. What else do you know? Give me another one higher then.
3 to the 4 is 81.
Did you have that memorized now?
No, yeah,
Oh. I'm impressed. You're supposed to say, yep. Okay, so 40, what are we thinking? 40 would be closer to 27, right? So what am I thinking?
3.2.
Approximately 3.2. I like that guess. My little squiggle means approximately equal to because it's just a guess. And I know the real answer, but I never told you my secret. Remember that one?
No, because you gotta round up.
That would be what it actually is. That's the exponent, but I'm not telling you my secret. Okay. So I did that completely without a calculator, though. These questions, that's what it'd be for. Do you notice how I didn't write x equals? I didn't write x equals. Did you? Because you shouldn't.
You have to do that squiggly equal signs.
My squiggly equals is just telling you that
Remind me.
it's an approximate equally.
So,
'Cause
yeah.
a- Yeah, that means approximately equal to. Okay, find the value of this log. So you might hear my directions say evaluate. On a test, I probably say evaluate this. So get me the number. So first of all, I'm going to tackle this. What is the exponent that makes that happen? So what's your brain doing right now?
Changing.
This is what your brain is doing. What's the exponent? Do we have that one memorized? Because that one should be memorized. 3. Okay, so I'm going to rewrite that with a 3. Okay, now I'm resetting and I'm thinking, what's the exponent that makes this happen. So my brain is thinking base 3 exponent equals that result. So what's the exponent? 1. So that's the answer, not x equals 1. It's just that this all comes to 1.
Can you say equals 1? Or do you
That's fine, but don't put like x equals 1 yet.
And so then the log 2 to the log 2, 8 is 3 is the 3, and then log 2.
Right, I did that. That was 3, yeah. And then I kind of replaced it with a 3, and then I evaluated.
How did you get the 1 now?
Because my brain thought like this, right here.
Yeah, but mine's not doing
Okay, well, what's the base?
3.
3. What's the result?
3.
3. So what did that exponent have to be? Yeah. Okay, log rules. How can I get to a 45? I have a 5 available and a 9 available. Log rules only allow me to connect with something multiplying, dividing, or exponents. And remember, exponents include radicals. Okay, so what's a way I can produce a 45? I have a 5 and a 9 available. You said times? Okay, what do we do with log when it's held together with multiplying? What could we do to separate them? Add. So log A5 plus log A9. And then I will just be doing this. I just took those values from up above, right? You see where I'm getting those? Okay. Oh, this is too easy. Like on a test, I probably would have been like, how can you get log A of 8.3333? Like that would be something I might do. Because I can, it's too easy for you to see 25 and the 3. Okay. So how can we rewrite this? I only can use 5s and 9s. So 5 squared over square root 9.
If you did 9 to the half, that'd be right too.
Yes, that's what I'm going to do next. Then I need to understand that that's that. Okay, log rules. When it was glued with division, I'm going to separate with subtraction. Every time I see an exponent, it's going to move to the front. So 2 log A5 minus a half log A9. I was gonna skip that other question there, by the way. I skipped it on your notes, so I skipped it here. Okay, write with a separation. So how many different units are there going to be when I separate? How many? 3. 1, 2, 3. There's going to be 3 separations. So log A5. Then what? Plus 3 in the front, log AM, minus 4 in the front, please remember this. If I separate something like this, there would be 2 separations, right? Like this x minus 4, it can't also split because it's connected with subtraction. It's not like you can subtract it or something like that. Okay? Does that make sense? Don't, that would be that one, yeah. Don't separate something like that. That one always seems to trick people.
So that's all we have to do is just break it up.
That would be like that. It just says separate, yeah.
Is this an easy one or this hard?
I gave you one like that on the test, like just separate, like that.
You have one like the
This next one. Oh, I don't know. I'm just saying, just don't. Okay, put together. So log B of log B and tie it all together. So we have a 4. It will be on the top. Plus the M stuff is on the top. So I'm going to times the square root of M. M to the half, yep. And then the subtract, so this is going to go on the bottom. Did you write n to the 5th? Okay, what's your first instinct? How to start? We need a first instinct on these.
Log 6. Like you separate the x, y, and the 2. You put the log 6 and the 2 and then 5 equals x, y.
Like changing the form?
Yeah.
Not yet. I can't do that yet. I like that idea, but not yet. Taking the log away?
Canceling both line the log.
What's that?
Combine the log.
Combine. Glue it back together. I thought you were trying to get rid of it. Okay, put it together. Those were both log 6's with an add. So that means I will multiply. Do you notice how there's a bracket that would be very key to be writing that? So put it together. That was my first instinct. Now what? This piece? Yeah, I can, but that will come. That's the algebra stuff. So just tell me a strategy though. That's algebra, we will do that. What's a strategy to do right now with the log strategy stuff? Into the other thing. Change the form. So how do I change it? So I'm going to be moving it into exponential now. So what to the what equals what?
Log 6 equals 2.
The base of what to the exponent what equals result what?
6 to the 2 equals.
6 to the 2 equals. And then this, so Gavin says, can we also FOIL that? So can I do that now? Is that okay with you if I'm doing it? X squared minus 5x. Now, this is obviously going to be 36, but what's another math strategy now? A grade 11 equation solving strategy. I need to equal 0. You okay? I'm changing that to 36, right? Okay. Now, do we see it? We're going to factor. I think I'm nice enough that I give you factorable ones. I don't want to have to make you go through all this and then use the quadratic formula, all of that in one question. That'd be fun, wouldn't it be? 9 times 4. Okay. I'm not committing to these answers yet. Why? I have to check these ones. So if 9 was in here, 9 would be positive. 9 minus 5, positive. I like that one. Negative 4, oh, that's not good. It makes that be negative and that be negative. Okay, another log equation. So what's your first log equation instinct?
Combine.
Combine. So log 3. So I'm combining that because that was separated with subtraction. So the combination is division. Okay, what's different now than we did last time? So last time we said, hey, let's change the form. There's a log 3 on both sides. So we're just going to say, hey, if that's log 3, then this has to be equal. Okay, now algebra stuff. What do you want to do? Times by x minus 2. So 16x minus 32. I think I'm going to subtract 16x. That's okay? Okay, so x equals, and I would just leave it like that. Ooh. Are we still okay when we check it for positivity? 32 over 15 minus 2 is still positive. We're still good because it's higher than 2, right? Okay, so log equations, think log rules. Always glue together. That's always your first instinct, okay? Exponential equations. Well, first of all, we learned there was some type with the same base. This is not that type. Do you see? It's not the same base. So what do we do with our first instinct on exponentials? Log them. So I'm going to log both sides. So everything's opposite of each other. Did you notice how logs, we glued them together? Exponentials, we log them and separate them. So our strategies are completely the opposite. Does that make sense? Okay, can you separate this with all those rules? So log 5, there's a multiply, so plus. The exponent is going to move into the front of log 7. Equals exponent moving to the front. Okay, there's the log rules. Multiply, added, exponents have all moved. Okay, I need you to give me that distribution. So plus x log 7 plus 3 log 7. Okay, now when you look at it, everything with an x in it needs to be on one side, and if it doesn't have an x, it will be on the other side.
How come we don't have to FOIL out the 2x?
This,
Yeah.
because it's not a binomial. Did you do thinking it was like this?
No, I just thought because it was, I put the 2x in brackets and then it just.
Yeah. Yeah, so 2x is just one term. So x plus 3 is a binomial, so then I have to make two terms. Yeah, I don't know. Does that make sense if I say that it was good? Okay, so now I'm going to take the x out of this group. Okay, do we know what we're typing in? We're going to be typing this divided by this. Let's hopefully all get the same answer. So I'm going to be typing it in with brackets, that unit divided by that unit. And I know some of you with your extra brackets, you're going to have to think bracket, bracket. Who said that?
Is that wrong?
That's what I got too. Two of us,
I got it.
three of us make it right. If you are still struggling with the calculator piece of these, then let me know. Maybe you would like to try one of these wonderful calculators because they're the best with logs. Okay. Exponential, so what's our first instinct? Log both sides, and then you said we're going to natural log both sides because I saw an E. So we're going to natural log both sides instead of log. And you're not wrong if you log both sides, it just gets a little messier. So this one only has exponents moving to the front on the rules. Okay, so the purpose of me doing that ln instead of log is because the ln of e is 1. Okay, on this side, I'm going to have to do that. Okay, so that's always our step, look for distributions. Next, x stuff one side, non-x stuff other side. Be careful with signs, positives and negatives. Take the x out. Oh, you already have an answer. I'm not even there yet. So on this one, I will be for sure putting that in brackets to make sure I'm doing that right. That would be what I'd be. You said 12 something? Is that what you said? I had a 12 point something as well. Matches? Not on this one. 3 ln 5 divide bracket 2 minus ln 5. Okay. Oh, you just did 2 times? Okay, so the word problems. I have 3 word problems on your test already. And they are the 3 types. Your one is some kind of population growth. You have one that is some kind of bank money, and then one that is the pH. Okay, so here's our formula. Determine the rate for a city of growing population. So it went from 20,000 to 26,000 in 8 years. So A is the 26,000. P is the start, so 20,000, times E to the R, don't know, times time 8. Okay, what do you want to do first?
Try to find the D, the R.
I want to try to find the R, but how do I algebraically get there first? Divide. That would be helpful to make this look nicer. I'm going to go E to the 8R. If this number is rounded or exact, I'm going to go with it. It's 1.3. If it is not, I can't do decimals rounding there. I would just leave it 26 over 20 or something like that. Okay, now what? I want to start thinking about the R now.
Now you times the E to the 1, like times it.
I can't times these. I'm going to natural log both sides. You got to get the exponent R out of the exponent, and the only way to get it out is to log both sides, but specifically because I saw an E, I'm going to ln, natural log both sides. So the ln of 1.3 equals 8R ln E. right? Exponents move to the front. See how that's the only way to do this? Because now my r is out of the exponent, okay? ln of e, 1. So I'm just going to have to type this into my calculator. I just have to divide by 8. So ln 1.3 divided by 8. Yeah. On that, I'm going to round to 3 when I write it, but I'm still leaving this in here. This is still in here. Don't erase it. Okay, what's the population in 20 years? So the population, it started at 20,000. E to the R times T. I wrote it like this because I'm trying to show you that I'm using the number that's in my calculator. That's me saying I'm not just using 0.033, I'm using this whole number. Okay, do we remember how to type this? I'm going to multiply it by 20, so it's in there, times 20 equals. Now what? Now I need e to that. I'm going to go e to that answer. So e to that answer. Good? Now I'm going to times by the 20,000. Okay, and this is people, so let's round to a whole number on that answer. So on that, you can round to a whole number. So please do not round your r while doing that. Wink, wink, hint, hint.
So we multiply those two, then
I multiplied e to that, then times. Just think bed math the whole time. Figure out the exponent, do the exponent stuff, and then the multiply. Okay, money question. So you're depositing $100 a month. The rate is 3%. So 0.03. Compounded monthly. How many pay periods till we get to 10,000? Okay, so here's our formula. So future value, so 10,000 equals P payments of 100, 1 plus the R with a decimal fraction to the number, I don't know, minus 1 over R. So please don't forget to move your percent to a decimal, and don't forget to divide it if it's compounded monthly, compounded quarterly. What would I do if it was compounded quarterly? 4. Okay, so filling it in, step 1. I'm going to do all my algebra moves at once here. So tell me what I could do here. I'll divide by 100. Gone. What else? Times by 0.03 over 12. Gone. Plus 1. That has to be done after those other ones, right? In that order. I'm going to do that. And then whatever I get, that's what I have left on that side. I did that, and I got a 1.25. Anybody matching? Divide by 100 times and add. Okay, how do I solve for n? I gotta log both sides because n is in the exponent. So I'm gonna log both sides. Okay, this is what I'm typing in, and let's see what we get. Okay, I'm getting 89.3, da 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 da. But what's my answer going to be? How many payments am I going to make at the bank until I have that much money? How many months is it going to take? Or how many payments am I putting in the bank? Because I'm putting a payment in every month. So how many months does this take me? I have to do it for 90 months. No matter what, you got to round up, because after 89 months, you don't have that much money. You can't drop down, right? Because now I probably only have $9,900 or something, right?